Hi, my name is Obed from Embedded Systems Academy. We are now on lecture number 3, and today we shall talk about basics of electronics. And so we simply going to do basic electronics. And so welcome to the course and to this lecture. There are various components of electronics that we will look into. The basic electronics that we can look at are batteries, the switches, the relays, the resistors, capacitors, inductors, transformers, and various semiconductors such as diodes, transistors, and many others. So for this class, we shall only talk about the first four: the batteries, the switches, relays, and resistors. In this class, we shall only need a basic knowledge of arithmetic and basic physics. There are no complex hardware and software in this class, and so you're good to go. Just basic arithmetic. So beginning with batteries, of course, an embedded system cannot operate without a power supply or a power source. So what is a battery? A battery is just a number of cells that are in an arrangement that are able to supply power to a system. Of course, a battery consists of cells, and each cell contains a positive terminal, or called a cathode, and a negative terminal, or an anode. But remember, in other devices which we shall see, anodes are treated as positive terminals and cathodes are treated as negative terminals. And this is the symbol for a battery or a cell and a battery. And of course, we have interacted with batteries all over in our places all the time, including your phone. It has batteries. And so these are very important in any system. Without power supply, without batteries, then this system is not going to be able to work. And there are various arrangements that we can do in a battery. And there are two factors. One is voltage, and there is also capacity. So the two arrangements, actually three: this series connection, and this parallel connection. There's also a combination of series and parallel. So when you want to increase voltage in a circuit, we arrange the cells in a battery in series. By series, we mean you connect the negative terminal to the positive terminal of the next cell, the negative terminal to the positive terminal of the next cell, in that sequence. And for example, if we have 4 batteries that are connected in series, as shown in this diagram or circuit, we will obtain a 6 voltage battery. So when these cells are connected in series, we have an increased voltage. So when we want to increase the capacity, we will connect these batteries in parallel. In parallel, that's where we have all the positive terminals connected together and all the negative terminals connected together. And in this case, there is no change in the voltage of the cell. So if the cell had 1.5 volts, then at the end of the circuit, we have 1.5 volts still. So the increased capacity here is that this arrangement is going to last longer, of course, depending on the load. That is the capacity. Of course, shortly we shall talk about battery capacity, and we will be able to understand more. Now, when you want to increase both voltage and capacity, then we do a combination of these two arrangements. We may have 2 cells in series, and then these 2 pairs we have connected them to another 2 pair, and then another 2 pair in parallel. We will obtain a 3 volts battery arrangement, and then we shall also have an increased capacity. So with these arrangements, we now in a system where you need to have 6 volts and you have 3 voltage batteries, then you're able to know how to do the connection so that you have the voltage that you need in your circuit. So what are the types of batteries that are there? The 2 types of batteries. There are primary batteries and there are secondary batteries. So primary batteries are those that are drained, and once they are drained, it's all over. So you don't even recycle them; they are just done. So most of them are carbon zinc batteries, alkaline batteries, mercury batteries, silver oxide batteries, and all those. Actually, they also come in certain packages. Of course, you've seen batteries labeled AAA, the capacity or voltage of 1.5 volts. AA, they actually change in size, and we have seen 9 voltage batteries, mostly in wireless microphones and some of our devices. So those are the kind of batteries that we have, primary batteries. Also, we have secondary batteries. These are the ones, unlike primary batteries, that are rechargeable. So once they're drained, they're then recharged, and they're able to be used again in a system or a device. For example, we have the lithium-ion batteries, we have lead-acid batteries, and other special purpose batteries. For instance, we have the battery on your phone. It's rechargeable once it's drained. So that kind of a battery is called a secondary battery. So of course I talked about battery capacity. See, when you want to know how long your battery can last, that's when we talk about the capacity of the battery. So its capacity rating indicates how much electrical energy the battery is able or capable of delivering over a period of time. You see, when you talk about your phone, you say your phone is able to stay a whole day without charging. And so that is the capacity of that battery. And the unit for battery capacity is actually ampere hours, or sometimes you may use milliampere hours. So the simple calculation there that you can do to determine how long your battery can last. So when we talk about ampere hours, it means your battery can supply a certain amount of amperes, that is current, for a certain period of time in hours. So the higher the capacity rating, the longer the battery can last. So maybe you will look into this example and understand more. But it's as simple as that. The higher the capacity, the longer the battery can last in a system. So another component in basic electronics is a switch. Of course, every system or device has a switch. And a switch is actually a mechanical device that interrupts or diverts electrical current flow in a circuit. But simply, a switch is something that you use to turn on or off. As simple as that. So if you, for example, have a circuit where you want to turn on a bulb or an LED, then a switch is used just to complete the circuit or open the circuit. So when you close the circuit or the switch, then the bulb lights, and when you close it or when you open it, it then goes off. So it's like an on-off device. And then sometimes you may want to divert a circuit. Maybe you have two bulbs, you want to switch on one and close the other one. So the switch then here acts like a diverter switch. And there are various kinds of switches that are existing. But before then, we may look at some things. When we have a switch, we may have two things. There's a pole and a throw. And for instance, a pole is a terminal or a contact in a switch. For example, this one, the terminal A, we call it a pole. And then a throw is a connection. For example, when we connect A to terminal B, this is a throw. And then when we have another connection between A and C, this is a throw. So we have double throws here. So that's why this switch can be called a single pole double throw. So it has a single pole and two throws. So a single pole, double throw. Sometimes we also have a single pole, a single throw. So those are the kinds of switches that we may have. And these are the symbols of various switches. A throw switch, a normally open push button, normally closed push button, and all these other ones as well. In our course, we shall interact with some of them. We have a toggle switch. A toggle switch is one that turns on and off. That is at one point it's either on or off. That's what actually the word toggle means, to either turn on or off. A push button is one that is momentarily. That is when you press it, it's on, and when you release it, it's off. Then we have a dip switch. It has many switches. And then it's simply another switch. There's a snap switch and many other kinds of switches. So we shall be using a push button in this course mostly, and these other ones can also always employ them in various scenarios in your system. So another component in basic electronics is a relay. A relay is an electrically actuated switch. Of course, we've talked of switches. Mostly they are mechanical. You have to mechanically push or connect them or turn them on and off. But a relay, they are actually actuated by an electrical circuit. And there are three kinds of relays. There are mechanical relays, there are reed relays, there are solid state relays. Mechanical relays typically are able to switch from circuits that are handling from 2 to 15 amperes, and reed relays can also handle typically from 500 milliamperes to 1 ampere. So they are just for smaller circuits, and they are moderately faster than mechanical relays. And then we have solid state relays. These are able to control circuits with from few microamperes to low powered packages up to 100 amperes. So these kinds of relays are able to handle even very large currents, and they are extremely fast in terms of switching speeds. So some limitation of the both reed relays and solid state relays include the switching arrangements and the tendency to become damaged by surges in power. So the best relays that we have are solid state relays that are powerful and able to switch relatively faster, and actually very fast, some of them. So these are pictorial representation of some of them. We have miniature relays, there are miniature relays, and there are reed relays. And we shall mostly interact with miniature relays in our projects and even in our circuits in this course. And this is a solid state relay. They're very fast. They actually use transistors in their operation. So a simple relay circuit is like this one. It's actually a DC actuated switch, where we have normally in a relay circuit we have two circuits: the actuating circuit and the load circuit. And so this control circuit, the one actually controls the load circuit. So for instance, we have 6 volts that is controlling this relay, that when you turn on this circuit, then this other circuit also turned on. When you switch off this circuit, this other one is circuit. But now they are mechanically separated so that there is no connection between this circuit and this circuit. Maybe as an assignment, you can find out the purpose of this transistor in this circuit here. So it actually acts as a transient suppressor, but you can find out what exactly this means. Another very common component in electronics is a resistor. You will rarely find a circuit without a resistor. So resistors are electrical devices that act to reduce current flow and at the same time to act to lower voltage levels within circuits. Later on we shall talk about Ohm's law that defines the relationship between voltage across a resistor and the current through it. So a resistor are used in various applications just to set operating currents and signal levels in a circuit, to provide voltage reduction, and in some precision circuits it's used to set gain values, and there are many other applications of resistors in a circuit, and we shall be seeing some of them in this course and in this lecture actually. So there are various types of resistors. There are fixed resistors, and this means the value of resistance is fixed. And then there are potentiometers and trimmers, also called variable resistors. In this case, you manually vary, you're able to manually vary the value of the resistance of the resistor. And then we have thermistors and phototransistors. There are also variable resistors, but now you don't manually do it. Actually, they are controlled by other factors. For example, a phototransistor, the resistance value of this device or component is varied depending on the light condition of the environment. And also we have photoresistors as well. So these are also other kinds of resistors. So basic resistor operations, as we said earlier, they are used to either limit current, divide voltage, and also divide current. So this we shall also see practically in some of the circuits we shall develop. As a current limiter, if your load needs a particular value of a current, then you may use a resistor to limit the current that is passing through the load. Also in voltage division, we may have, for example, 5 volts, and we have a component that is using 3 voltage. So we will use a resistor to divide the voltage so that some of the voltage is dropped across the resistor, and the remaining voltage now is appropriate and usable in the device. Also in current division, you may arrange 2 resistors so that at the end of the circuit we have a particular current flowing through the circuit. So those are the basic applications of resistors in a circuit. And when we shall be looking at the circuits, of course they have various values, as I said earlier, and they are labeled. Any resistor is actually have a label. So there are various labeling standards. There are 4-band, 5-band, and 6-band resistors, and they are always colored. And so depending on the color band for the resistor, you're able to determine the value of the resistor. So for instance, if we have a 6-band resistor, normally you will see a gap, a big gap between where to know actually this is to be able to indicate which direction are you going to read these bands from. So you always begin from the end where the most number of bands. On the other side is actually to measure tolerance. Tolerance is to show what is the range of error for the resistance value. So you may have a 6-band, the first color, you check it against the table. You may be able to master this, but always this chart is always available. You can refer to know the value of the resistor. Again, later when we shall be practically looking at the resistors, we will determine the value of the resistor we shall use, and we shall use this table to determine the value of that resistor.